Continental Glacier, it's an enormous feature in terms of, obviously, its size. I mean, this is going to take up an entire continent, thus the name, but also in terms of its thickness. I mean, these are places in which, at times, a continental glacier, in its largest, it's a mile thick. So look up, and that's a mile, and that's nothing but ice. So obviously, massive features, so big that they actually pushed down the land down into the asthenosphere, especially during the most recent ice age. So we're not in an ice age, obviously, right now, but when an ice age does occur, these continental glaciers advance and become much, much larger in terms of their area. So these are going to be much larger than mountain glaciers. So mountain glaciers kind of confined within the walls and the confines of the mountains that they live in, whereas continental glaciers obviously don't have that, nothing holding them in. Most of Earth's glaciers are continental. In case of the northern hemisphere, Greenland is where you see the largest continental glacier in the northern hemisphere, and in the southern hemisphere, our good friend Antarctica. Ice sheets, another key term, just essentially a continuous mass of ice covering a large landmass. So continental glacier and ice sheets are often synonymous. So Antarctica and Greenland are two areas in which a continental glacier and ice sheet exists today. And maybe in the future, way after we're gone, these ice sheets will grow as another ice age occurs. Let's go back about 3 million years ago, if you don't mind, and you'll notice here there's something missing. There's no Great Lakes, and if you know your Canadian geography, there's no Hudson Bay up in particular up here in Canada. So what happened here? So essentially, this was before the most recent ice age, which is about 125,000 years ago, roughly. We have this particular image here that shows that glacier that previously was up here in Greenland, advanced because of a cooling period and then compaction of snow and so forth, which I'll show here in a minute. So you can see the limits of this continental glacier 125,000 years ago expanding. Of course, today, this glacier is retreated and it's back over much of Greenland today. So how did this happen? How does a glacier, a continental glacier, how does it advance? Of course, we get a cooling period, but what happens is just similar to what we've shown beforehand. Over time, snow accumulates, not going to melt, and just think about pizza dough. If you got a big old glob of pizza dough and you push down on it from the top, you push down on the top, what's going to happen is that pizza dough is going to spread out. And so the same idea here is we're adding weight, just like beforehand I was adding my hand to the pizza dough, my weight to the pizza dough. And so what ends up happening is the glacier, as more weight is added, as more snow falls and it's frozen, it then essentially forces the advancement of the glacier at the front of the end. And so we've got the same terms we've talked about beforehand, the zone of accumulation, the zone of ablation, and the equilibrium line. Same idea here as glacier, in this case continental glacier, works as a conveyor belt to bring that debris, it's plucking, at everything, it's bulldozing, and brings it to the front, which is very important when we think about one key feature that we see along the border or the end of a continental glacier. So finally, I'm just going to look at this particular map here. We've got the Rocky Mountains and the Appalachian Mountains, and so the most, I guess, of the last few glaciers that have come through here, this is the largest extent, or the farthest extent south, we'll say. And so if you notice, where does this particular glacier end? Well, it ends right about where the Ohio River is and right about where the Missouri River is. And so these rivers formed essentially at the end of a glacier, at the end of its advance.